Hi everyone, I am Dr. G. Sarojini, Associate Professor, Department of Chemical Engineering, Hindustan College of Engineering and Technology. In this video, I am going to discuss about azeotrope, which is a part of Chemical Engineering Thermodynamics 2. So, what is azeotrope? It is a mixture of two or more liquids whose proportion cannot be changed by simple distillation. That means it has same boiling point. This azeotrope occurs because when the azeotrope is boiled, it produces the vapor and the proportion of the constituent in the vapor and the mixture which is not boiled will be the same. And this azeotrope occurs even after distillation, the composition will not change. The composition remains unchanged. Though the word azeotrope is now commonly used for describing this phenomena, in olden days it is termed as constant boiling point mixture. Azeotropes are mixtures of at least two liquids that exhibit the same concentration at the liquid phase and the vapor phase. Azeotropes do not follow Raoult's law. It means the mixture is non-ideal solution and they shows deviation from Raoult's law. According to Raoult's law, the partial pressure varies directly with the mole fraction. So azeotrope will not follow Raoult's law. In azeotropic mixture, one component has either a higher or lower boiling point than the other component. In these mixtures, the component exhibits the same mole fraction in the liquid phase and the vapor phase, so they cannot be separated by ordinary distillation. Fractional distillation, it is a simple technique used to separate a mixture of two or more miscible liquids for which the boiling point difference is less than 25 Kelvin. Another condition for fractional distillation is that the components of the mixture must have equal mole fraction at the liquid phase and the vapor phase. So, the fractional distillation is used to separate different gases from the air, different fraction from petroleum products. Like so, the apparatus for fractional distillation is almost the same apparatus like the simple distillation, but in the fractionating column, a distillation flask and the condenser will be installed. Features of azeotrope. So these azeotrope, they are binary mixtures with one solute and one solvent. For example, in ethyl alcohol azeotrope, ethyl alcohol is mixed with water. Ethyl alcohol will be the solute and water will be the solvent. The solute and the solvent both will be in the liquid phase. For example, in a mixture of azeotropic mixture of ethyl alcohol and water, both ethyl alcohol and the water will be in the liquid phase. Then the solute and the solvent are taken in fixed compositions to form azeotropes. For example, in an azeotropic mixture of ethyl alcohol and water, 96% of ethyl alcohol and 4% of water are mixed. These azeotropic mixture boils at a constant temperature. For example, an azeotropic mixture of ethyl alcohol, that is 96 mole concentration, and 4% water boils at the boiling temperature of 78.10 degree. The separation of the constituents of azeotropic mixture by fractional distillation is not possible. For example, as the mole fraction of ethyl alcohol is same as the liquid phase and in the vapor phase, and the mole fraction of water is almost same in the liquid phase and the vapor phase, so the azeotropic solution of ethanol and the water boils at 78.10 degree and they cannot be separated by simple distillation or fractional distillation. So what are the different types of azeotrope? So the different azeotropes can be divided into different types based on their composition and the deviation from Raoult's law. That is, the first one will be the positive azeotrope, or it may be termed as minimum boiling azeotrope. The second one will be negative azeotrope or maximum boiling azeotrope, and the third is heterogeneous azeotrope, fourth homogeneous azeotrope, fifth binary azeotrope, and ternary azeotrope. Positive or minimum boiling azeotrope. These azeotropic mixtures which show large positive deviation from Raoult's law or specific concentration are termed as positive azeotrope. They show boiling points lower than the boiling points of their constituents. That's why they are called as minimum boiling azeotrope. This type of mixture exhibit the highest vapor pressure and the lowest boiling point. For example, in an azeotropic mixture of 96% ethanol and 4% water, it exhibits positive type of azeotrope. It shows a large deviation from Raoult's law. This azeotropic mixture has a boiling point of 78.2 degrees Celsius, where the water boils at 100 degree and the ethanol boils at 78.5 degree. Negative azeotrope or maximum boiling azeotrope. These azeotropic mixture which shows large deviation from Raoult's law or specific composition is termed as negative azeotrope. They show boiling points higher than the boiling point of their constituent. That's why they are termed as maximum boiling azeotrope. This type of mixture exhibit lower vapor pressure and the highest boiling point. For example, an azeotropic mixture of hydrogen chloride and water is a negative azeotrope. It shows a large deviation from the Raoult's law. These azeotropic mixture boils at 110 degrees Celsius, whereas the water boils at 100 degrees Celsius and HCl boils at 84 degrees Celsius. Heterogeneous azeotrope. If the constituents of azeotropic mixtures are not completely miscible, then the azeotropic is found inside the miscibility cap. So, space splitting may occur for the minimum boiling azeotrope with a large deviation from Raoult's law. This leads to the formation of minimum boiling heterogeneous azeotrope, which has a vapor phase in equilibrium with two liquid phases. The constituents of these azeotropes are not completely miscible. These type of azeotropes are called heteroazeotrope. For example, an azeotropic mixture of chloroform and water. When they are shaken together and left to stand, then they form two separate layers. This mixture boils at 53.3 degrees Celsius, where the boiling point of water will be 100 and chloroform will be 61.2 degrees Celsius. Homogeneous azeotrope. If the constituents of an azeotropic mixture are completely miscible in all proportion with each other, then this type of azeotrope is called a homogeneous azeotrope. For example, any amount of ethanol can be mixed with any amount of water to form a homogeneous azeotropic mixture. Binary azeotrope. Azeotropes that have two constituents are called binary azeotrope. For example, a mixture of diethyl ether 33% and haloethane 66%. This azeotropic mixture is commonly used in anesthesia. Ternary azeotrope. The azeotropes that have three constituents are called ternary azeotrope. For example, an azeotropic mixture of acetone, methanol and chloroform. So what are the applications of azeotrope? So when we consider the application, it is used in testing gas chromatographs, detectors and columns. These azeotropic mixtures are used for the separation of different constituents. For example, it is very difficult to separate pure acetic acid from a solution of acetic acid and water. As we know, ethyl acetate forms an azeotrope in water and boils at 78 degrees Celsius. So by adding ethyl acetate in a mixture of acetic acid and water as an entertainer, it is possible to distill away the azeotrope of ethyl acetate and water, leaving pure acetic acid in the distillation flask. So the boiling point of acetic acid will be 118.1 degrees Celsius. Thank you.